Hello everyone, today let's solve the problem number 309, best time to buy and sell stock with Cooldown, right? So what the question states here, we are given an array prices. You can clearly see here, we are given an array prices where iterated value of the prices represents the stock price on the 8th day. This is nothing but the each element is nothing but the stock price here, right? So iterated value of the prices represents the stock price on the 8th day. We need to determine the maximum profit that we can achieve by making as many transactions as possible. However, there are two conditions, so we have to find out the profit here, right? By making as much as transactions possible, they have completely given here. So what are the rules here? Only two conditions they have put here. One is we must sell our stock before buying again. So first thing, if I buy this stock, before buying another stock, I have to sell this stock. That's what they have given here. And after selling, we must wait 1 day as cool down before buying again. So after selling one, uh, we have to sell, suppose we sold this one on the second day, so we have to go with the cool down on the third day and then again buy and then again sell. That's what they have given here, right? So first day they have given buy, so let's buy this one. Sell on the second day means here we will sell this one, so profit will be 1 in this case. uh, then again we will go for the cool down, because again to buy we have to go for the cool down, right? So we will go for the cool down. Again we will buy this one. Again when we sell, this one will be 2 minus 0. This one we will see. So the output will be 3 here in this case. How it is 3? Let's see this one in the approach, right? So let's consider the second example as well. We have only one element, so we cannot we can buy this one, but we cannot sell this one at all. So the output will be, in this case, it will be 0, right? So let's consider this one first example for the approach. Let's see, let's discuss the approach step by step, followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the approach. So here I have considered the first example, same example, right, that they have given in the question. The first example that they have given in the question. First thing that we have to remember here is we will be going with the dynamic programming, or DP here. So we will be going with the DP here. So just remember this one. So the first step here would be we have to identify all the possible transactions here. So we have 1, 2, 3, 0 and 2. Day 0, what we will do? We will starting from the index 0. So we will be considering day 0. This is 0 indexed. Just keep this one in mind. So that is the reason we will be going with the day 0. We will not start from day 1. So day 0 will be going with 1. They have given 1 here, right? So we will buy at 1. Second day we have to sell. After buying, we will be selling this one. So we will get a profit of 1, right? 2 minus 1 is nothing, but we will get profit of 1. We will be selling at 2 here. We'll buy at 1 and we will sell at 2. So the profit will be obviously 1 here. Third day, after selling, 1 day cool down they have given here. We will go for the cool down here. So I will not consider 3 here. So this is third day. So then third day or day 2 here. Day 0 we have started from, right? So day 3, this will be again we will buy for 0, right? So we will buy at 0 here and we will sell at 2. When we have bought for 0 and when we are selling that one for the 2, profit will be obviously 2 here. 2 minus 0 is 2 here, not 0. Sorry, 2 minus 0 is 2, not 0. This is fine. So now the profit here is 1 and this one 1 and 2. On the day 1 we got profit of 1 and on the day 4 we have got profit of this one 2. So when we sum up this one, the total profit that we got here is 3. So here let me come here. Total profit that we got here is 1 plus 2 here we got 3. This is the approach that we'll be going with. I hope this is clear how we got 3. And the second example we have already considered that one. We got output 0 because we were able to buy but we were not able to sell at all, right? So that is the reason. So here let's go with the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written, right? So let's discuss the edge cases one by one here. The first edge case that we have that we are considering here is only one, because we cannot sell here, so the profit will be quite obviously zero. We have already discussed this one in the second example. So here the second example we are going with here is all increasing prices, nothing but in this case 1 2 3 4 5 we have. So the output will be here, just give me a second here. So here output will be 2 in this case. So we will buy on day 0, and we will buy on day 0, and we will buy on sell on day 1. Then this will be the cool down, this will be buy, and this will be sell. You can just calculate in the same way that I had showed for the example 1 in the approach, right? So the output that we will get here is 2. Let's go with the third edge case, all decreasing prices. So here the output will be 0 in this case, not this one. So the output for the third edge case will be 0, because no transaction is possible at all, because we are making use of all decreasing prices, right? No transaction will be possible at all. If we buy this one, we cannot sell for 4, we have to sell for greater, right? We have to gain the profit here. No, all the, suppose if we are not considering this one, at least for the further elements, if we consider the same, again we cannot buy this one at 3. Suppose this is cooling period, let's leave this one. Again, if we buy this one at 2, we cannot sell this at 1, right? So here no transaction is possible at all, so the best profit here is 0. So I hope this is clear. Next, the final edge case here is alternating high low. So here 1 3 2 8 4 9, all the alternating high lows we have, right? So the output will be 13 in this case, right? So we will buy on 1, sell on 3, then cool down for this one, 2 cool down. For 8 we will buy on 2, will sell on 3, again this one will be cool down, right? So just give me a second. Buy, sell, this one will be cool down, again we will buy this one and cool down, buy on 4. Yeah, this is fine. The output that we'll get here is 13 for this. So these are the 4 edge cases that we have to consider. The first element, the first edge case was for single element. The second edge case was for all increasing prices. Third edge case was for all decreasing prices. Fourth edge case was for alternating high low. Right? This is the 4 edge cases that we need to that we considered. Now let's start writing the code. So here let's initialize. We'll be making use of the length of the prices many times in the code. So let me assign this one to the variable, some variable. I'll consider n, and let me give here prices dot length. This is fine. And we, as we had discussed, we'll be going with the dp array, right? So let's consider here dp equals array of size n plus 2. Just for the easy calculation, we'll be going with n plus 2 here. Let's fill this one. Initially we'll be making use of fill here and map. Why I'm mapping this one, we are going with the 2D array here, right? So this will be array of 2 dot fill of 0. This is fine. Fill of 0. I hope this is clear. So let's go with the for loop. We have to go with the iteration, right? We are making use of the 2D array again. So 2 for loops here. So let me give here for let n equals let I'll just go with I and j. I equals n minus 1 in this case. Reverse iteration, I greater than or equal to 0. Then let's decrement the I here. This is fine. Next, let's consider the variable I j, or let me consider b here. So b here, b equals 0, b less than 2. This will be, let's increment the b in this case. Why we are doing this one? Because we have to go with the buy, sell and cool down, if you remember, right? Buy on the first day, sell on the second day, and third day, 1 day is for the cool down. That is the reason this for loop, right? So I hope this is clear. Next, inside the for loop, what we will do, case when we do nothing on day 1. So when we are not doing anything on the day I, right? So or day 1 it will be wrong. Case when we are doing nothing on day I, we can tell it in this way. So I'll just give here dn, let me consider dp of I plus 1 here and b. This is fine. So the next step here, I'll just consider simple if condition, if b, right? So if b means here, in simple terms we know this, if we can buy, then we will choose max between, right? So if we buy, then we will choose the maximum. First what we will do, if we can buy, we will choose max between skipping buying and keeping profit, nothing but dp of I plus 1 and b, right? So as we are going with a 2d dp here, so or buying today and subtracting price of I from future, price of dp of I plus 1 and 0. That's what we did in the approach, right? We bought today and we subtracted price I from the future profit, nothing but dp of I plus 1 0, as we are dealing with the 2d dp array. So this one we can articulate in this way, in the form of code in this way. So I can just give here dp of I b, this one will be equal to math.max of dn and dp of I plus 1, and this one will be 0, this is fine, minus prices of I, this is fine, prices of I. So just give me a second here. Yeah, this is fine. Else what we will do here, else if we can sell, we will choose max between skipping selling and keep profit, right? Or selling today and adding price to future profit. That's what we can do. So again, how can we articulate that one in the form of code? This one will be dp of I b, same thing, I would have copy pasted and made the necessary changes here. So this is fine. Let me give here math dot max of dn, instead of dp of I plus 1, this time it will be dp of I plus 2, and instead of 0 this will be 1, right? So plus normal, this one will be same, prices of I. So this is fine. So the final step here is uh, we will get the maximum profit starting from day 0 in buying state, right? So we can just represent this one d in the form of dp of 0 and 1. So I'll just return the same thing. So it will be dp of 0 and 1 here. This is fine. So let me format this one once and let me hit the run button. So I hope this works. Let's see. So you can clearly see the sample test cases are getting passed here, right? So let me hit the submit button very quickly. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case, right? So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is dynamic programming. We know this one. So overall time complexity would be here big O of n. Why it is big O of n here? Because we are iterating over the prices array once from back to front. So here you can clearly see we are iterating over the prices array once from back to front, nothing but the reverse iteration. So overall time complexity would be big O of n. What will be the space complexity here? Overall space complexity would be big O of n as well. Why? Because we are making use we are using dp array of size n plus 2. You can clearly see here this one. Initially itself I have said we'll be making use of the dp array of size n plus 2, right? So this is the reason overall space complexity would be big of n as well. So just give me a second here. what happened. So this will be because of n. So the overall time complexity and the space complexity would be because of n, right? So I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.